Okay, so here's our exciting example too, right? This person is going to give it a push for some distance. They might actually be, they might actually be an Olympian or something. I don't know how fast they'd have to go, right? But they're going to push it for some distance, right? And that's what we want to figure out, right? It's already going, before they start to push it, it's already going 4.6 meters per second. And they can push forward with 53 newtons, right? And their goal is that when this cart is at the top of the hill, okay, that it will be going 2.4 meters per second. So I think this is the before picture, this is the after picture, right? Before, I think one of our assets is that force times the distance, right? So I think we've got force times distance as one of our assets. I think the cart is already moving before, so it's also got 1/2 mv squared, right? And that's it. It's not on top of a hill, and right? So those are its total assets. When it's on top of the hill, I think it's got potential energy because it's gone up a hill, and then it's also moving, right? Now this force times distance is on this side because it's a force that speeds you up. It's an asset, right? So now I think we're set, right? The force is 53. The distance is what we're trying to find, so we'll leave that as d, right? Plus 1/2 350 times 4.6 squared. That's supposed to be a 6. Okay. Equals, let's see, mass 350 times 9.8 times 1.8. Okay, plus 1/2 350. And then we want it to be going 2.4 at the top of the hill, right? There we go. Such a long equation. Well, what I'm going to do is I'm going to take this guy here, this entire side, and I'm just going to bust that out and add it together. So I'm going to go 350 times 9.8 times 1.8 plus 0.5 times 350 times 2.4 squared. Let me make sure that's exactly what I typed. Indeed it is. And I get this whole side all added together is 7182 joules is what it is, right? And then 0.5, let's do this whole thing here. 0.5 V times 4.6. That's 37. Okay, plus 53 times d. Well, what we do now is I go this minus this, and then I'm going to divide by 53. Okay, so 7182 minus 3703 equals, okay, so 53 d equals 3479, right? And now I just divide. You want to, when it's multiplied by that, you want to divide, right? So that divided by 53, and I get that d equals 65.64 meters. Now we only have 2 digits there, and 2 digits there, and 2 digits there, and 2 there, right? So we have to actually round that. That's about 66 meters. Okay. Good example. This, by the way, I call this a 2 to 2. Okay, two things become two things. This is like basically it's the height of the art of writing one of these problems, you know. Hope you appreciate that.